Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes, okay? So we're going to talk about slant asymptote of a rational function, okay? We're going to talk about slant asymptotes. Please don't forget to review previous video. I've talked about the horizontal asymptote, I've talked about vertical asymptote. I've introduced the concept of a rational function and the general form of it. And if you've not shared, subscribed, or liked this video, I don't know what you're waiting for. Please don't forget to click on the notification bell so that when I post new videos, you'll be the first person to know. All right. Okay, so let's do this. So quickly, as usual, you should be conversant with this already. The general form of a rational function. So it's f of x is equal to px divided by what? Q of x plus d. And or you can also have that the numerator can be a constant. Okay, so you have f of x is equal to a over bx plus c plus d, all right? All these are forms of rational function. Or you can also have a constant and a different polynomial. So regardless, you're going to have a rational function is a ratio of polynomials, okay? So, but remember, for this to be true, I told you that q of x cannot be equal to 0, or bx plus c cannot be equal to what? 0 for this to be true. Now, a slant asymptote, we're going to talk about now. So, but a slant asymptote, similar to the horizontal and vertical, is an imaginary line to which a part of the line appears to, a part appears to touch, will touch at a point in infinity, okay? But one of the things as well is, like I said, is that like you have something like this, and it comes very close, but it's not going to touch as well, okay? Now, before I go in to explain the concept of how to find slant or oblique asymptotes, there is something I need to say quickly, all right? Now, one of the things I want you to know is that the only time, okay, the only time you can have a rational function that has a slant asymptote is only when the degree, okay, the degree of the numerator is exactly 1 greater than the degree of the denominator. So if you have a particular rational function and you notice that the degree of the numerator is just 1 above the degree of the denominator, then you can be expecting to have a slant asymptote for that rational function. In the previous video, what we're talking about the degree of numerator and the ratio for what we talk about the horizontal asymptote, I explained to you the concept of degrees. I also explained to you the concept in polynomials. So when we say a degree, it's talking about the highest power of x in a particular function, all right? So what I want to just say is that a rational function has a slant asymptote only when the degree of the numerator is exactly 1 greater than the degree of the denominator. So I'm going to write it down because I know some of my students do take note. So a rational, all right, a rational function has a slant asymptote only, okay? Only when, so it's only on this situation or in this scenario that you can have a slant asymptote. When the degree, okay, of the numerator when the degree of the numerator n is exactly 1 greater, okay? Exactly 1 greater than the degree of the denominator. Okay? So the rational function has a slant asymptote only when the degree of the numerator is exactly 1. So what I'm just trying to say is if, for instance, the degree of the numerator is 3, the denominator should be 2. Is that making sense? If the degree is for the numerator is 4, the denominator should be 3. So the difference between the numerator and the denominator must be just 1 above. Okay, so that numerator will just be 1 degree above that of the denominator. All right. So let's get started now. All right, so let's go. What are the 3 rules in order to find the slant asymptote? Number 1, before you start, you have to ensure that the degree of the numerator is exactly 1 greater than the degree of the denominator. Okay, after you rewritten it in the general form. So when you have the rational function, make sure it's in the general form. Then look at the degree of the numerator. Look at the degree of the denominator. The degree of the numerator must be 1 greater than the degree of the denominator. So you have to ensure the degree of the numerator is exactly 1. So it has to be exactly 1, okay? Exactly 1 greater than. So it has to also be greater than, okay? Than the degree of the denominator after writing it in general form. Okay? So when you've done and you've seen that the degree is of the numerator is just 1 above, then the next thing you have to do is that you have to then divide the numerator by the denominator using long division. So number 2 is then you have to then divide the numerator by the denominator using long division. And number 3, when you've divided the numerator by the denominator, then the quotient from step 2. So remember in long division, if you've not watched my video on long division on how to do long division, please go back and do that. So I gave you in the video, you just go to the playlist and search for long division. We have when you have missing terms of x, I talked about different types. So I assume you know how to do long division for you to apply these rules here. So if you've not, just go to the playlist and try as much as possible to remind yourself about how to do long division, okay? And I told you that after long division, you're gonna have a quotient and a remainder. Is that okay? You're gonna have a quotient and a remainder. So the quotient you get from the equation in step 2 is gonna be used to obtain the slant asymptote, okay? So the quotient from step 2, so the quotient you get from step 2 is the equation to obtain the slant asymptote. So remember I said it can be called slant asymptote or you can call it oblique asymptote. So you can use any of them. All right, so the first thing you do, you ensure the degree of the numerator is exactly 1 greater than the degree of the denominator. When you're done, you have to now divide the numerator by the denominator using long division. Then after you're done with that, the quotient you get from step 2 is in the equation is what you use to obtain the slant asymptote, okay? So let's pick an example here, all right, to make it easier. So let's assume that you were told that, number 1, they want you to find the slant asymptote. Okay, of the function. So you're told to find the slant asymptote of this function. we have y is equal to x squared over x plus 1, okay? We have this, for example. All right, so let's solve this question and see what we can do. So the first thing first, step 1, we need to ensure that the degree of the numerator is exactly 1 greater than the degree of the denominator after writing in general form, okay? So you have to then write this in general form. So from this already, it's already in general form. So y is equal to x squared over x plus 1. So plus d is equal to 0. So now let's see. Now, what is the degree of the numerator? Degree of the numerator is 2. What is the degree of the denominator? Is 1. So that means you can see the degree of the numerator is 1 above this. So that means this, we should be expecting a slant asymptote from this. All right. So now we're going to go to step 2. Now, what does step 2 say? It said that you have to divide the numerator by the denominator using long division. All right, so let's go with long division again. So step 2, please, if you've forgotten long division, please go back and have a look at it. So we're going to have x squared divided by x plus 1. So remember, I told you that this is a classical example of long division with missing x terms. So that will now give us x squared plus 0x plus 0, okay? Then we're going to divide now. So x in x squared will give you x, you multiply. X times x will give you x squared. X times 1 will give you what? X, or 1x. Then you subtract. X squared times minus x squared will give you 0. 0x minus x will give you minus x, and you bring down 0. So that'll be plus 0. Okay, now the next thing you now repeat the process. You divide, you multiply, and you subtract. I talked about this. So please, if you've not reviewed that, please go back and have a look again. So x divided by minus x will give you what? Minus 1. Minus 1 times x will give you minus x. Minus 1 times plus 1 will give you minus 1. All right? Then we'll subtract. Minus x minus minus x. Minus times minus will give you plus. So this will give you 0. Then 0 minus, so it will be 0 minus minus 1. So you have in 0 minus minus 1. Minus times minus will give you plus. So it'll be 0 plus 1. And that will give you what? 1 here. All right. So that is it. So we've gotten it. So remember, this is now the quotient. And this here is the what? The remainder. All right, so we talked about this earlier. All right, so the next one, they said the quotient from step 2 is the equation to obtain the slant asymptote. So that means the quotient here, so that's called, let's call that step 3. We've got to step 3 now. Okay, the slant asymptote, the equation for the slant asymptote, okay, will be equal to x minus 1. And that will be the answer for the equation of the slant asymptote. So with this now, there are other steps to do an analysis, but it's beyond the scope of this video, okay? But the equation to get the slant asymptote is going to be x minus 1. And in the next, when I get to slant asymptote analysis in the video, we're going to talk about that later. But just how to get the equation of the slant asymptote is what you do. So you just make sure the degree of the numerator is greater than that of the denominator by 1. It has to be exactly 1 greater. Then when you've done that, you do the long division. The quotient you have there is going to be the equation of the slant asymptote. Okay, and that will be that for that. That's where I'm going to stop. The next one, I'm going to go straight now to graphing rational functions. So now we know how to find the vertical asymptote. We know how to find the horizontal asymptote. We know how to find the equation of a slant asymptote. So now we have all the tools necessary to find what? To sketch a graph, to sketch a rational function graph. Okay, so I'm going to see you in the next video where we're going to sketch rational function graph. And like I always say, if you've not subscribed, if you've not shared, if you've not liked it, I don't know what you're waiting for. Please don't forget to do so. and click the notification bell so that when I post new videos, you'll be the first person to know. All right, so see you soon.